Hey guys, how you doing today? It's Dan Banks here. Today we will show you a little simulation of blocking for round bifocal segments as well as a blended bifocal segment, which we don't see very often, but I did have a sample, so I figured I would include that in this video. So for the purposes of this video, we are going to use a round bifocal for the right lens and a blended bifocal for the left lens. Obviously, we normally wouldn't do something like that in practice, but the act of blocking them is very similar to one another, so I figured I would include them both in the same video. As you can see here, I've already taken my frame measurements. I have my patient measurements and my binocular PD and my seg height, and I've already calculated my horizontal centration and my vertical centration over here on the right side of the sheet. So you can see all my measurements there. And now I'm going to go ahead and block the lenses up. So again, we're going to start with the right lens is a round bifocal, and this isn't actually a round bifocal, it's a simulation where we just drew a round segment on the lens because we didn't have one at hand. But as you can see, my centration is going to be 5.5 millimeters in per eye and 6 millimeters down per eye. Again, with all multifocals, we need horizontal and vertical centration. So all the math is written out there for you. You can kind of double check my work, make sure I'm accurate. I'm pretty sure I'm in good shape there. And we'll go ahead and start to block. Now we're going to turn over to the blocker. And I'm going to have to zoom out just a little bit here. There we go. So I'm going to start with my right lens, and you can see that we can clearly see, oops, dropped it. We can clearly see our three dots for the distance portion. One here, and one here, and we can also see the top of the segment. So our major reference point, consistent with all other segmented lenses, is going to be the top and the middle of the bifocal segment. So I will always start that right about here. So you can see up at the top here I'm at 0 horizontal centration. So the first thing I'm going to want to do is move to 5.5, which is right about there, and then my vertical grid's already in place. So now I'm going to go ahead and move my segment over to my 5.5 in. I'm going to zoom in a little bit so we can see a little bit better. So again, my goal here is 5.5 millimeters in and 6 millimeters down. The bold line here again is 5 down. That is this one right here at the tip of the PD stick there. That's 5 down. So we're going to move 1 millimeter lower to 6 down. We also have our 5.5 in. So here we need to pay close attention to where the sides of our segment falls. You can see that the left side extends out past that vertical marker, where the right side isn't quite to the vertical marker. So I'm not quite centered perfectly there yet. I have to move this over just a little bit for accuracy. So now you can see my simulated segment, that orange or red line extends beyond those vertical hash marks just a little bit for each of the lenses. That'll ensure that my lens is centered. So that is what a round seg would look like at 5.5 in and 6 down. And then, as always, I would go ahead and block the lens and check for accuracy. For the left lens, we are going to use a blended bifocal. And before we move right into blocking it, I'm just going to give you a little bit more insight, show you a little bit more what's going on here. This is an actual blended bifocal. When I bring the segment up towards the camera aperture, you can see the magnification in the segment. And blended bifocals have these pre-marked ink dots all around the edge of the lens. You can also see one down here in the center of the bifocal. Here the segment is a really large part of the lens blank itself, and so you can kind of see that. There's a little optics there, right? Little width motion, a little plus lens action there. So now we're going to block this as the left lens. So I'm going to zoom back out. I'm going to bring my slide back to 0, back to 5.5 millimeters the other way, and we still need 6 down as well. So when I get my lens in here, this one's a little tougher because it doesn't have lines. It has a series of dots, okay? But you can see that right around in this area up here, you can see these 2 dots are going to serve as the very top part of the segment. These are just marked all the way around so we can see where the edge of the segment is. I'm going to zoom back in. I'm going to shore this blocker up a little bit. And so now I have my 5.5 in. You can see down at the bottom, see these dots here? There's one here on the right and one over here on the left, and these are both extended just a little bit further out of those 2 vertical dash marks, so they're pretty well centered there. That's pretty much perfect there. And then the 2 dots on the top of the segment have to be at our 6 down. That's what we wanted there. So that's an example of a blended bifocal at 5.5 in and 6 down. Again, we can see our 5.5 in. Well, that's about 6 in. Let me move that over just a little bit. 5.5 in, 6 down. And that looks to be in pretty good shape there. So again, in practice, we wouldn't do a blended bifocal for the left eye and then a round seg for the right eye. But since I had the blended bifocal, I figured I would include that in this video because the act of blocking it is very similar to one another. What I'm also going to go ahead and do is I'm going to go back to the round seg for a moment. And the round seg is interesting in that this here would simulate a lens that has some cylinder in it because we have our 3 dots in the distance. But what's unique about the round seg is that if it's a spherical lens, the round seg is the only lens that we can control the distance PD and the near PD in the blocker. I'm going to show you how we would do that. So the first thing I'm going to do is if we assume that this round seg is spherical, I'm going to take these outside marks off because I don't actually need them. Okay, so now all I have on my lens here is I have my round seg itself, the ink markings, and then I have my distance dot there as well. If we go back and we look at the measurements for this job, we need a 65 distance PD, 62 near PD, along with the 12 millimeter seg height. So we have a total inset here of 3 millimeters or 1.5 per eye. That's from the distance to the near PD. So what we can actually do here with this lens is we can set both the near and the distance PD with this lens. I'm going to show you how. So first we're going to dial in our 5.5 millimeters in, and we're going to move our segment to our 6 millimeters down, like so. Okay. Now we can see here that the center of the round segment and the distance OC are right in line with one another. Here's the center of my bifocal. My distance OC is right up top here. But when we have a spherical lens, again, we have the ability to set both the distance and the near. So since we need 5.5 in for the segment, that's for total centration, but we have a difference in binocular PD of 3 millimeters. When you split that in half, that's 1.5 per eye. So now what I have to actually do is dial back my distance PD 1.5 millimeters like so. You can't do this with any other type of lens, with a flat top lens, because as soon as you twist it, you twist the segment itself. But because the bifocal is round, you're able to do this. So for this lens, we would need a total centration of 5.5 millimeters in, but then the distance centration only needs to be at 4 millimeters in. So you can see, here's my distance PD, here's my distance centration of 4 millimeters, and then you can also see that the segment, well, that segment's a little crooked, that needs to be shored up a little bit. So my distance PD is at 4 in. No, my near PD is pretty good. They're at 5.5 in. So that's what's unique about the round seg, that only if it's spherical we can actually control the distance and the near PD in the blocking phase prior to edging. Every other lens we have to rely on the labs to accurately place the distance and the near PD for us. So I hope this provides some insight. I hope you enjoyed watching. Talk to you guys soon.